Okay, so let's take a look at how we would solve this problem and create our roadmap. So we're starting with 755 grams of carbon dioxide, and we want to know how many carbon dioxide molecules are there. So there's some words that would give us clues. Notice that we have grams. So if we're thinking about grams, we would know that there's only one conversion factor, only one that would fit, that would cancel out the unit of grams. It wouldn't be Avogadro's number, and it wouldn't be the subscript conversion factor. It would have to be molar mass. So that's a clue to us that we need to use molar mass. Another clue would be the word molecules. That would be a clue that we need to use Avogadro's number. All right, so let's take a look at solving this problem using our chart to help us create the roadmap. So here's our chart. This right here is another way to look at the subscript conversion factor. I like to use it just with the moles of an element and a moles of a compound, but if you wanted to, you could look at it with atoms, the number of atoms of an element in one molecule. I prefer to use moles because that's what we're doing most of the time, and it just makes things easier. So I would take care of that, take that out. Now, what are we starting with? Well, we're starting with the 755 grams of CO2. We need to think about the starting units. This is where we are, right here in this box. This is our starting box. And then we think, well, what do we want? Well, which one of these boxes is what we want? This box is what we want. So we are going to move from the starting box through our conversion factors to the want box. So here we go. We're starting here, grams of CO2. Our first conversion factor is going to be molar mass. Now we remember where molar mass comes from. It comes from the periodic table, so we would need to go to the periodic table and add up our molar mass. It's always a good idea to use more sig figs than what we are starting with so that we avoid rounding errors. Here at least we need to go to the 10th. I would go more. I would always go more than less. So this chart also helps us know which conversion factor are we talking about. Should we put 44 grams on top or should it be on the bottom? Well, it needs to be on the bottom so that our units will cancel. This tells us we need to cancel those units, and the next box tells us this is what we need to have on top, as we see here, so that our units do indeed cancel. All right, now let's move to the next conversion factor. So here we go. This is Avogadro's number. Again, moles of the compound is what we need to cancel out, and molecules is what we want. So molecules is going to be on top so that our units cancel. And of course, we always remember that it is 6.022 times 10 to the 23rd molecules of CO2, not 6.022 times 10 to the 23rd moles. This is always in 1 mole. So our units have canceled, and there is our final answer. So you can use this chart to help you come up with the roadmaps. So practice with this. It's going to take some time and a little bit of patience, but keep at it and you'll be able to do it very smoothly without the chart.